Hello, I'm Dave Burchetti, and today I'm giving a little talk, hopefully a dialogue with some folks about kids learning how to program computers. And let me just take a look at my outline. I'll introduce myself. I'm a software developer for many years, and I've been teaching kids to program for quite some time as well. I teach in a summer program in Pleasant Hill, California called Diablo Valley College for Kids. And I've just started some classes in the Lafayette, California area. In fact, this morning I had a new class of Python, mostly beginners, and that went very well. So I'm going to show you some of the software programs that exist for kids to learn programming. And hopefully you'll engage with YouTube or the Google Hangout in such a way that you can either bring your face here or type in questions. So if you see a link on YouTube inviting you to come and ask questions, you can type questions, or you can bring yourself here with the camera and a microphone and join in the discussion. Okay, so why don't we start with Scratch. So I'm going to make a little change here, and I'm going to share something in my browser, and that's coming up here. Okay, so you should see my browser, and here's this is Scratch. Scratch came from Massachusetts Institute of Technology, and a question came in, and it seems to be in a language that I can't read, so I'm afraid I can't do anything with it, but thank you for the question. I hope it's not bad words or anything. I'll assume it's not. So Scratch was built on top of Squeak, which is something that Alan Kay and other folks of Smalltalk fame created. And I taught Squeak for a while, and then found Scratch to be a little bit easier for the kids to use, but definitely not as deep and rich as Squeak. And then there are lots of other spin-offs from Scratch. I don't know if spin-off is exactly the right word, but things, tools that are like Scratch in some ways, like Tinker, which I'll also show. So this is, Scratch is online, and you're looking at my folders of stuff. So let's just start maybe a little higher. Here's the top page, and you can see featured projects. Let me just dispose of the question that I can't read. Okay. So I'll go to my project, and I'll just show you a couple of things. So here's a program that with this beetle, and the beetle will draw a square. This is the program here. This is called a script, and this is the what is it called? I'll think of the name of it in a minute. In Tinker, it's called an actor. Okay, a sprite. That's right. So let me click the green flag, and it does what it's supposed to do. So let's analyze how that worked. Go to -150, 100. That's the point at these coordinates. And then there's these things in green have to do with drawing with the pen. And so we cleared the previous drawing and then put the pen down and set the color and the size. And then we did what you do when you draw a square, which is to repeat 4 times, moving and drawing at the same time. And then I put a little delay in. There's an 0.8 of a second delay between the sides of the square. And then it rotates, and then it goes back. And once it's done, it clears the screen. I'll run it again. And there it is. So let me go back to my stuff and show you something different. This is one that we did at a Scratch class at Devox for Kids at the Hacker Dojo in, I believe it's Mountain View, California, recently. And I was asking for ideas from the kids for what to do, and they wanted to have an earthquake or a shaking building. I don't know if you'll be able to hear the sound. So after some prodding, I got some kids to come up to record the sounds of people in the building. So let's see what this does. This has a variable. It's adjustable. The magnitude is. You can vary the magnitude of those oscillations. And it plays the sound that we recorded, and then it just jiggles, really. It just turns clockwise and waits a little bit and then turns counterclockwise. And then this code increases and decreases the magnitude. So there are a couple of Scratch projects. I'll just show you what it's like to make a new one. I'll click New Project here. And the cat is one of many sprites that you can work with. There are lots of backgrounds and pre-made sprites, and you can make your own. And you can make things work with these tiles. So this has to do with moving, and you can have the scripts start when the person at the computer clicks the green flag. So when I click the green flag, this program just does this. I could go here and have the cat move and then say hello for 2 seconds, and then that goes away. Okay, so that's Scratch. Now I'll switch to Tinker. Oh, I see there's a question. Awesome. Can we access your Scratch projects for reference offline later? Yeah, absolutely. Thank you for that question. Let me select it to show that I'm answering it. So if I push the share button, I can share these projects. And my username is Dave Brick, D-A-V-E-B-R-I-C. So if you go to Scratch, you can take a look at those. You may find some that are a lot better, but you're certainly welcome to look at any of the ones that I've shared. Back to here. This one uses a relatively new feature of Scratch, or uses a new feature that's called cloning. And let's see, I did it this way. Okay, let's see. 1 second, I have to remember how this works. When the sprite is clicked, oh, right. So this is a tree. I tell my students that it should become obvious very quickly that I don't pay a lot of attention to the artwork. I'm more interested in the code. But this tree will produce apples when you click on it. So that's a new feature. You can clone things. So you write the code once to describe what the behavior is for one apple, and then when you clone it, the clones also have that behavior. This one's kind of fun. This one I wrote a while ago. Just waiting for, here we go. All right, so this is the player character. These are obstacles that will kill the character. Here's the goal. And using the arrow keys, we have to move the player to the goal without touching any of those obstacles. Okay, so you might think, well, that's ridiculously easy, but here's the tricky part. The obstacles disappear except for those that are close to you, and then you disappear. So I'm going to tell you what I'm doing. I'm moving up, and I'm moving to the right a little bit, but I don't want that to get too dark because that means I'm too close to it. Oh, okay, I ran into it. So let's try it again. So I'm going to go up, and then to the right. Now you see, okay, so here's a little question for you. If those two dots are equally bright, what does that tell you about where I am? Now I'm moving to the right. Okay, so that's arrived. So I'm going down a little bit because I don't want to hit that. And here's another one. All right, so I want to kind of get equally between those, working my way up. I'm getting there. Yay, I made it. Okay, so that's kind of a fun one. Tinker. Tinker is a commercial product, so they make money from it, and they I think they earn the money because they do a lot of good educational material that comes with it. So just to give you an example, um, I taught using Tinker at the Diablo Valley College for Kids that I was talking about last summer, and on the first day of class we had some kind of power trouble, so I couldn't give the lecture to introduce them to Tinker. And we went right into the lab, and they sat down, and I told them where to go, and they started, and they followed the lessons, and they didn't really need the lecture. So that's kind of nice. Schools, I may be a little out of date on the info and the pricing and stuff, but I think it's still free for schools. And for folks who want to use it at home, it's $50, and that includes some very nice lessons. So let me sign in, and I have a teacher account. Okay, and I've used Tinker at several places. I'm going to talk about Hack the Future a little bit later. Hack in the good sense, I always say, the good sense of the word. Let me go to my projects here, and I'll show you just some simple ones that we made. Here's a growing player escapes maze. That's similar to one that I showed you. This is one. One day I brought in a hard drive and opened it up and taught the kids a little bit how it works. And then I asked them to make a simulation of the hard drive. I don't know the names of these parts, but the read-write heads are up here, and this is some kind of arm, and there's electromagnets that make it move. So this is supposed to be just a simulation. If you've ever seen a hard drive in operation, this is not too far off. And how does it work? Well, this is very similar to Scratch, as you might have noticed. Forever, which means just keep going forever, and it points in a random direction. So this actor, the sprites from Scratch are called actors in Tinker. It just picks a random angle from 60 to 90 degrees, and it turns to that, and then it waits 1/10 of a second. I guess a real hard drive would be a lot faster. Have a much faster, what do you call it, seek time, I guess, than 1/10 of a second. One thing that's really nice about Tinker is it has physics features. So let me see if I have a physics project. So let me first remember how to get back to my stuff. Here's one example. You see this start physics, that turns the physics engine on, and anything that's not anchored down will fall and possibly bounce and do other things and interact with other objects as would happen in the real world. And so let me run this. Okay, so this ball bounces, and its restitution, I think that's the word, is set to 1, which means it doesn't lose any energy when it, we're kind of ignoring air resistance and the friction from bouncing on the surface. And so what this thing does, it doesn't look like a blower, but when I click this button, it it imparts a force against the bouncing ball. And on the Young Programmers podcast and YouTube, I've got a video that shows this physics stuff and explains it. Let me just direct you to the video. In fact, I might just play a few seconds of it here through the Hangout. I'm just copying the URL here. Let's see if I can do this. Okay, YouTube. Here it is. Okay, so you should all see the same video. Click on Add Videos to Playlist. Add Videos to Playlist. Paste in and go. Now I'm going to jump ahead a little bit here. So I've got a cannon that fires cannonballs. And it'll fire lots of them. Indeed. So here it's actually shooting the balls. This is kind of the finished result. If you're interested in how it works, you can watch this, the whole video. Pause. Okay, so let's see if I can get back to the other place here. Good. Here I am again, obviously. And my browser. Okay, great. So I've shown you Scratch, told you a little bit about the history of it, starting with the famous and brilliant educator and computer scientist Alan Kay, and leading to Squeak, and then Scratch, and then to Tinker. And what do I have next on my agenda here? Oh, I think it's time to get into Python. So I need to switch to a different program here. Let me get these ready. When I do these videos for the Young Programmers podcast, I edit out all these pauses, but you have to endure. Okay, almost ready. I'm going to share this. Okay, now this one I'm not sure you're going to be able to see it, but let's try it. I'll have to make a little adjustment. This is a program written using Python and Pygame. So Python, you find it at python.org. Let me just see. I have to make a change here to show the running program. This is it. Now, I have no idea if you see it. It's animated. You should see sort of a lawn of clover and then a bee buzzing around, and the bees moving around to pick up nectar from the flowers. So this is the beginning of a graphical 2D game that's written in Python. So I'm going to press Escape to make that go away, and then I'll show you a little bit about the code and how that works. The B program is in several source files. So this is what Python language looks like, and you I don't know whether you saw it, but the title that appeared was "Bee Get the Nectar," and then I'm not going to walk through all the code. Don't worry. This loads an image, and there's something about drawing the title. and a bunch of rendering and blitting and display flipping and stuff. And the end result is that simple, the beginning of a game. Okay, now to something simpler. And I think I have to switch to the different window. So let's close this one, see what happens. Comes back to me, and then I'll share this other one. And let's see if it's this one. Okay, good. So this is a much simpler program. Obviously, this one is just several lines long. I like to turn on line numbers. So this is 11 or 12 lines long. And I'll run this one. And the results come out here. And what you're seeing is 10 simulated single die throws from a 6-sided die. So here are these numbers. And the point of this is just to show how you might use randomness in a game. And maybe it's a game where there are actual dice, or maybe you have a game where you just need to randomly choose among several possible events that might happen in a place. Here's another something like this. It's a little bit more complicated. You might have an idea just from reading this what it is. It's a high-low guessing game. And let me close this. And some other ones running too. Okay, so here's the whole program in 23 lines. I'll run it first, and then I'll explain a little bit of it. And you can see down here the program is running, and this is the text that comes out. So welcome to the game. Integer between 1 and 100. And I showed this to a Python class this morning, and the students all devised a strategy for making smart guesses, and the strategy is dividing the set of numbers in half each time. So 50 discards half of the numbers, and so that's too low. And then halfway up again is 75, and so maybe 85 is not quite exactly right, so maybe 90, and so we know it's somewhere in here. So pretty sure it's 86. So we got it in 6 guesses. So let's look a little bit at how the code works. Random is a module, and parts of Python are organized into these units called modules. And Jesus says hi, and I will say hi to Jesus. Jesus or Jesus. That wasn't a question, but I am glad to get the hi. It's nice to have that interaction. Okay, so importing the random module makes random features of Python available to us. This causes the message to come out that you saw. And I have some variables like what the person's guess is and how many guesses we've had so far. And this line produces the random, or for you mathematicians, the pseudo-random number integer between 1 and 100 inclusive. And then we have a loop that keeps the program running as long as the guess is wrong. And here we ask for what the guess is, and we see if the guess is matching the number. If so, we say congratulations, otherwise too high, otherwise if it's too high, we say too high, otherwise we say too low, and then we show the number of guesses. Okay, I want to show now a little simple adventure game here. It's all text. Very short, one file. This is it here. This game has 3 places and transitions from one place to one or more other places. And the starting place is chosen randomly. Oh, here, let me run it. It's not very fun or anything, but it's the beginning of what you might do and some examples. And I'm I'm so glad to have the question that I'm going to pause and answer that. Which text editor or IDE do you recommend for Python? Python comes with something called idle, which is a good starting point, but I doubt professional programmers would use it because it lacks a lot of the features that we like. For a while, I used Eclipse with the PyDev plugin, and then for a while I used NetBeans. And now I've discovered Pycharm, which is what you're seeing here. This is Pycharm, Pycharm, and they have a free community edition, which is what I'm running right here. And it comes from the same company that makes IntelliJ IDEA, which is my favorite IDE for my professional consulting programming work in Scala, which is a nice language that runs in the Java environment. So a lot of it is familiar to me, and I can have breakpoints and examine variables and do all kinds of very powerful things in an interactive debugging mode while I'm running. Okay, so I think I should have selected that first, and then, because I wonder if these get made into a little table of contents or index or something in the final YouTube product. Okay, so hopefully that answered that question. So Pycharm is my favorite now, but other people may like others. Okay, so what more do I want to say about this? Oh, I'm running it. That's right. Okay, so we're at the forest. We can go to the airstrip or the cave. Let's go to the cave. Oh, okay. Well, thanks. You were struck by lightning. Game over. That happens on average 1 out of 10 times, as you can see from this. So that was unlikely that would happen, as in life. Here the odds are a little bit less favorable for you. Okay, so I think maybe that's enough of that. I'll show one more because Python is useful for so many things. You've seen, hopefully seen, the 2D games and text-based games. People like to make web apps too, so maybe students want to make a web application, which is just a game or something that runs in the browser, like Firefox or Chrome or Safari or whatever. So let's see, a web. Here in these, I need to figure out how to get it to keep the line numbers on. I just started with Pycharm a week or so ago. I haven't spent that much time with it. So this is one of the shortest web application servers you could write in Python, and I'm going to run it. And you might notice that there's a 8000 here, and this is the port that it's going to be listening on. So let me run, and then I'll go to the browser. So I have to make a little switch here. Go to the browser, and I'll set that up, and then I'll switch it over. Okay, so I might get good at this eventually. Hello again, and back to the right one here. Here it is. Okay. Whoops, that's not the right one. Sorry, I went back to where it was. Embarrassed face. And we want the browser. The browser. That's it. Okay, good. So if you're running your own web server or web application server on your computer, then you don't go to google.com or somewhere else. You go to localhost. And I'm going to go to 8000 because that's the port that I chose. And when I go here, then this is what appears. It says your random number is 22. And I'm going to jump over here and select this question, which is, well, I'll be doing Visual Basic. You know, years ago, I taught Visual Basic and enjoyed it very much. And then I started to develop a sense that I wanted to work on free open source stuff that works on all the platforms. So I didn't want to be a Microsoft-centric person. So I stopped teaching Visual Basic, I don't know, maybe 10 years ago, and somebody, a friend suggested that Python would be a good first language instead of that. So so I switched. So if you were looking for VB, I'm sorry I won't be able to do anything for that. Okay, so, but thank you for the question. Your random number is 22. Well, how did that happen? Well, here's some code, and I won't get into all this. With web application, you have HTTP requests like GET, and here the response to a GET request is this HTML here that includes the body that says your random number is, and then a random number gets substituted into this. Okay, so I think I've shown enough Python and Pygame, and now I just want to mention some other things. So I think I'll show my face here. Let me set this one away and go back to here. So hello again. And let's take a look. Okay, so I want to tell you about some other groups. The lessons that I'm teaching I'm doing it for profit, so I'm charging. There are lots of fine groups around the Bay Area and elsewhere that do this for free. And I have a link to those places, so let me just grab that and go there. And I got to switch the screen again. I'll show you that in a minute. But there's one group called Hack the Future. I mentioned it earlier, and I always say hack in the good sense. It's not breaking into people's computers. It's robotics and software and designing applications and learning how to solder. Various other things. The most popular thing there is Minecraft modding. And a lot of kids like playing Minecraft, and Minecraft modding is when you add your own weapons or features to the game. And you do that in some language that runs on Java, on the Java virtual machine. So either Java or Scala or something else. So that's very popular. That's not something I've gotten into myself, but boy, is that a popular station. Another is Unity 3D, which is free with some restrictions in the license. And at the end of the Hack the Future day, I think I'm going to show you the Hack the Future pictures now. The kids show their accomplishments. So let me get that in the browser. Give me one moment. Okay, I have the pictures right here. Great. Okay, so these pictures are from Hack the Future 10, which was in the Dublin, California library. These events are, most of them have been in the South Bay, in the San Francisco Bay Area, Mountain View. Someone says, I like MC. Oh, so that's Minecraft. Okay, good. You came to the right place, Caleb. Not that I'm going to have much to say about it, but I'm glad for you, and you might be interested in this Hack the Future. So the adults who help the kids are called mentors, and we're volunteers, and sometimes we wear silly hats so that we identify ourselves to the kids. So I'm just going to zip through some of these pictures and tell you some things. They're doing Python at this table, I think. And this is a high school kid who just came and brought some books, and he knows a lot about physics, and so he had people come and ask him questions about traveling at the speed of light and things like that. And a few more pictures here. At this station, you make, using kind of arts and crafts types things, you design a mobile app or something like that. This young man is one of the few, I don't want to say child mentors, teen mentors, and he knows all about Arduino. So he has these little computers with sensors and motors and stuff. So if you go to Hack the Future, you spend some time at his station, and you can build some very interesting projects. This girl has got an Arduino here. An Arduino is a little board, and you connect it to your computer with, I think, a USB cable, and you write a program in a language called processing, and then you send the program to the machine, and then you run it, and it turns motors and things like that. This is soldering, and this is where I finally, at age 54, learned to solder. Well, I'm very proud of it. And the guy leading the soldering station is the one and only Al Alcorn, who created Pong for Atari way back in the day. Not made out of computer chips, but out of electronic parts. And Al Alcorn is also was also Steve Jobs' only boss at Atari. Steve Jobs came to work there, and on contract, he wrote the game Breakout. And at night, he would be there, and his friend Woz would come by, and they would work on the game together. I'm sure you can read that story in the old legends, the history of the internet. Okay, so what else here? This is a 3D printer over here, so the kids make their 3D models in Google SketchUp, and then they print them on the printer. 3D objects. Okay, a little more soldering here. Al Alcorn, another view. Here's the guy who likes to talk about physics and his enthralled, I was going to say minions, but that's not the right word for that. Students. Okay, let's see what else. Just kind of zipping through. Here's somebody making kind of like a prototype of an application. This is an oscilloscope, and when I learned how to solder, we made these little kits. We made a blinking LED out of these kits, and it was great fun. There were 4 resistors, 2 capacitors, 2 transistors, a switch, a battery holder, and of course the LED. And if you hook it up to the oscilloscope, you can see what's happening with the voltages over time. So time is on the x-axis, and the voltage is on the y-axis. This is a circuit diagram of what we made. I still don't understand it, but but I did a good job soldering it, and I'm glad. Here I am, sitting next to Al Alcorn. Closer look at the project. More with the Arduino hacking, and this is a sensor. Okay, now we're coming. Here I am holding up the thing that I soldered. This is the guy, and I missed an opportunity. I should have had Al Alcorn himself teach me to solder, because then I could have said for the rest of my life that I learned to solder from Al Alcorn. But it was this other nice guy, I can't remember his name at the moment, who taught me, and he did a really nice job. He actually, Al, like me, is kind of old and slightly, I'm not going to say gruff, but what's the word towards that? This guy was a little gentler. Here we are at the show and tell at the end of the day. So kids come up, if they did something on their laptop, they bring their laptop and they show it and they project it on the screen, and this is what we're seeing here. And so you'll just see a few pictures here. These are, I think, someone tell me if that's Minecraft. I'm pretty sure it is because of these blocks. So I don't know. One guy made like a goat who poops diamonds or something really strange. And then this, I think, is Unity 3D. This guy, along with his mom, created the Tri-Valley Hacker Dojo, which is a free group in the Dublin area. They meet at the Dublin Library on the first Wednesday of each month. Is this Minecraft? I think so. This is Scratch. This guy had a Scratch program that uses the camera to move this rocket around with his hands. And I think that's Minecraft again. And I think somebody made, maybe this is a web application. Here's the audience. This young girl made a website, so she learned how to do some HTML and CSS, cascading style sheets. HTML stands for Hypertext Markup Language. This looks like Scratch. Here's what somebody made with an Arduino. It's a little cart that moves and stops when it senses something. This is Google SketchUp, so somebody made this, modeled it, and then printed it. And I'm not sure if this is what we're seeing here. This is, so you model it in 3D on a computer, you send it over to the printer, and an actual 3D object appears. This guy was very pleased with himself because he made a web page that caused annoying pop-ups to appear and never end, and so he learned something from it. So it wasn't all bad. Another Arduino project, and that's the end of those. Okay, so how are we doing on time? I changed the time to an hour, and we're at 42 minutes right now. So let's see what else I have planned here. Let me put this away. Okay, so Minecraft modding, Unity 3D, other groups, Hack the Future photos. So let me just show this page with the other groups. So let's see, open URL, let's see if that'll come up. One second. That's interesting. I'm going to meetup.com and I'm getting a, you know, they got attacked with a distributed denial of service, DDoS attack. And so maybe that's what's happening. If you go to meetup.com, young programmers, I'll put it here, and look at the in the discussion section. One second here, I'll just put it right here. Actually, I could have just told you quicker. Meetup.com/young-programmers, and young, the Y in young, and the P in programmers is hyphenated. Is capitalized. So meetup.com/young-programmers, capital Y, capital P. Okay, let's see. Did I do what I wanted to do? Yeah. I think that's all the prepared material I have. I'll hang around, see if we have questions. Otherwise, I'll say goodbye shortly. The meetup.com is where I'm publicizing the Dave Burchetti's Young Programmers classes that will be around Lafayette, the Loma Linda area. And I have one starting on next Wednesday that is a Scratch class for grades 3 through 8. It's an hour and a half in the afternoon. This is the advertising part of it. From 4 to 5:30 at the Lafayette Library, and it costs $17. And so you can see that on meetup.com. Okay, so let me go another 30 seconds, see if we get any questions. I'll think of something else to say. Oh, here. This is my project that I soldered. Can I get this to look right? Yeah. Oh, let me turn it on. Gee. See? Isn't that nice? Now, I know you can get a little blinking LED that's all in one unit, but Al Alcorn said that that's no good because you don't really know how it works because it's just like a little computer thing. But here, if you study that circuit diagram, you can figure it out. Okay, time to say goodbye. Thanks for coming. So long.